Okay, so in this video, what we need to do, we need to focus on this area of the machine, and that's the cuvette holder. The cuvette holder is very important because if you use the wrong type of cuvette, then you're going to end up getting wrong numbers for your data. And if you get wrong numbers for the data, then your laboratory is basically trashed, and you're going to have to start all over and get a zero for it if you turn it in a little bit later. And if you're working for a company and you use the wrong cuvette holder and you analyze all the samples, good luck to you because they're probably going to get mean and nasty. All right. So the cuvette holder is basically holding the cuvette. And we've talked a little bit about the cuvette in previous videos. That's kind of a lopsided, fat little cuvette, but you get the deal. So the width of the cuvettes are typically 1 centimeter. That's normally the width of any cuvette that we work with in a laboratory, no matter what kind of material the cuvette's made out of. The 1 centimeter cuvette, that's why we always put 1 in Beers's law. So A equals EBC. We said that B was the path length, and the path length is the path length of the cuvette. And typically it is 1 centimeter. Not every single time, but most of the time it is a 1 centimeter cuvette. We have various cuvettes that are out there to choose from. And sometimes we will not use a 1 centimeter cuvette. And we'll talk about why, and we'll talk about what those look like. But for the most part, 1 centimeter is the way to go. There are 3 different materials that the cuvette could be made of. Okay, and we're going to have to talk about each one of these 3. First, we could have a normal plastic cuvette. All right. Now, these plastic cuvettes are disposable. So a lot of times in a laboratory, they are one-use cuvettes, and we can throw them away. Just trash them. The reason is because they're plastic and they're pretty cheap. I mean, they're literally like pennies a piece. Anywhere from 1 penny to 3 pennies a piece is what we normally pay for plastic cuvettes. However, in our laboratory, we like to rinse them out, and then we like to go through and dry them, and that way we can reuse them over and over and over. Why waste? So plastic cuvettes are great. However, plastic cuvettes can only measure in a certain range. And plastic cuvettes can only go from 400 to 900 nanometers. That is it. So plastic cuvettes are meant for the visible portion. So basically what that means is that if I have something that measures at 274, then I cannot use a plastic cuvette for that purpose. Plastic is only good for 400 to 900 wavelength. That is it. So these are colored solutions basically. So if I'm working in the visible region, these are colored solutions most of the time. And if they're colored solutions, then I can use plastic. If they're not colored solutions, then I need to think about it for a minute because plastic's probably not the material of choice. So 4 to 9, visible, colored solutions. That is when I use the plastic cuvettes. All right? Okay, the second version of a cuvette will be a glass cuvette. And the glass cuvettes are not one use. All right, so I'm going to put a big X here. They are not one use. We do not throw them away. Now, the purpose of the glass cuvette. Sometimes, when we make solutions in a laboratory, I will put it into a volumetric flask and I will dilute up to the line with solvent. And sometimes the solvents do not like plastic. They can actually eat plastic, or they can start turning the plastic cloudy. And if I am making a sample in a lab and I'm using one of those solvents that cannot come in contact with plastic without destroying it, then I probably don't want to use plastic cuvettes, right? Because those plastic cuvettes will start to decompose and start to melt and start to turn cloudy, and then I can't run those in a UV vis instrument. So I have to have another material to choose from. Well, these are not as cheap. Glass is used for that purpose. They're more expensive. That's why they are not one-time use. That's why we don't typically trash them when we get done with them. But that's the purpose of the glass cuvette. All right. So over here to the side, glass is still used for the visible spectrum. It still goes from 400 to 900 nanometers. It's still used for colored solutions. The only deal is that with the glass cuvettes, this is for solvents that can't come in contact with plastic. Okay? So for instance, acetone. If I squirt acetone on plastic, it's going to start turning it cloudy. And that's something that I want to prevent. So the third and final type of cuvette that we might see in a laboratory is called a quartz. And the quartz is kind of the best of all worlds. The quartz is not one-time use, okay? And the reason is because it is so expensive to order and purchase. These things are close to $150 to $300 a piece, depending on what type that I need to get, and if I need any certification with them or not. So these are definitely not one-time use, and of course, you do not trash these at all unless you just want to waste money. All right. So the quartz cuvettes, what's the good thing about those? All right. Well, the quartz cuvette will actually do 200 to 400 nanometer. So this is the first type of cuvette that we've seen now that will actually do the UV portion. If you look at the plastic, that's for visible only. If you look at the glass, that's for visible only. But here we've got quartz, and quartz is the first type of material and really the only material that we will see in a laboratory that will use UV. All right? However, quartz is even better than that, because quartz can go from 400 to 900 as well. So quartz can also do the visible portion of the spectrum. So it can do the whole onslaught, which again is probably why it's most expensive. They know that this one cuvette can do everything that you need, but the problem is that these are breakable, just like the glass ones are, and they can crack and they can chip, and you can completely trash them without meaning to on accident. All right. So the quartz is UV 2 to 400 and visible from 4 to 900. They are also great with solvents that are organic in nature, because a lot of times the organic ones will eat the plastic. That's why we had the glass cuvettes for the visible, right? Well, if I do use a solvent and it is organic and I can't use plastic with it, then quartz will stand up to that material. So quartz, glass, and plastic are the three types of cuvettes that we typically see in a UV vis instrument, and those are the materials that I typically will be exposed to when I'm running samples and things on the instrument itself. All right. So these cuvettes, we've already talked about the shape that they take on. Some of them have cloudy sides, and then two of them are going to be clear. Others will not have that. Sometimes you'll see a little triangle up here at the very top that will tell you the side that needs to be measured. And then with this cuvette here, it's really narrow in the bottom, and this is to push all of your sample up, so you don't need as much in order to run. However, here are pictures of Cuvette cells that are not 1 centimeter in width. And here we see almost like a cylindrical tube that looks like a polarimeter cell, if you've used a polarimeter before. And then here are two plugs up here at the top. So I would unplug one of these, I would fill my sample into this UV cell, and then I would plug it back. These cells, you can run them in UV and you can run them in visible, depending on the material that you get them in. Again, you can get glass ones or you can get quartz ones. Here in the center, you'll see the same exact kind of thing. It looks a little smaller, but these are not 1 centimeter wide cuvette cells. They are different, and sometimes we need to use those. Now, why do we need to use a wider cuvette cell? All right, well, if 1 centimeter does not cut it for me, and I need something wider, then I will probably end up using one of those longer cuvette cells with the entries and outlets up here at the top. And this allows us to get some extra width in the sample chamber. The reason that I would choose to use something like this is if my sample is extremely weak and there's no way that I can make it stronger. Okay? So what would happen is that if I put it in a 1 centimeter cuvette that's really narrow, and the 1 centimeter cuvette is a really weak solution, I might get an absorbance value that is lower than 0.1. And we said that was our working range, right? Well, that's because it's really, really weak. Well, is there a way that I can take this really, really weak solution and still run it on a UV? And the answer is yes, I still can. What I would do is that I would get a wider cuvette, and I would take this really weak sample and I would put it into the wider cuvette, and that wider cuvette allows me to hold more sample. And if more sample is there, then it can absorb more. And maybe my absorbance is going to be greater than 0.1 because of that. All right, that's the reason that we use those really wide cuvette cells. Very rarely do we have to do that. But if you are given that option, or if you're giving the problem to solve this problem that we're having in a lab, that's one of the ways that you can fix that scenario. Use a wider cuvette for really weak solutions, and then that way you can get a higher absorbance value and put it on scale of where it needs to be. Now keep in mind, if you do use the wider cuvette cells, then all of your standards have to be ran with that cell, and then all of your samples have to be ran with that cell. So you got to keep it consistent, like always. All right, so if I look at the next piece, we've talked about the light source, we've talked about the monochromator, we've now talked about the cuvette cell. In the next video, we'll talk about the detector and how it's made and how it works. So 3 cuvette holders: plastic, glass, quartz. Quartz does everything, but they're so expensive to purchase. Plastic is cheap and it will do colored solutions invisible. Glass is cheaper than quartz, but it only does visible, only does colored, but it's meant for things that have organic solvents that would eat plastic.